function. Let's find the x-intercepts, which are the zeros of the numerator from our reduced fraction. Of course, this fraction is already reduced, so we take our 3x plus 5 and set it equal to 0. If we subtract 5 from both sides, we get 3x equals negative 5. And then divide by 3, you get x equals negative 5. So our x-intercept is the negative 5/3, comma 0. For our y-intercept, we just plug 0 into the function, f of 0. We get 5 on top and 2 on bottom. So our y-intercept is the point 0, comma 5/2. Vertical asymptotes are the zeros of the denominator. So we take our denominator, x plus 2, set that equal to 0, and we get x equals negative 2. And that's the vertical asymptote. Horizontal or oblique asymptotes come from looking at comparing the degrees of the numerator and denominator. They have the same degree here, which means that our horizontal asymptote is just the leading coefficients. Y equals 3 on top and 1 on bottom. So y equals 3 is our horizontal asymptote. Okay, now we're ready to sketch the graph. We've got our x-intercept at negative 5/3, which is right around there. That does have a multiplicity of 1, which will help us when we're actually graphing it at that point. The y-intercept is at 0, 5/2, and that's right there. And then our vertical asymptote at negative 2. And our horizontal asymptote up at 3. Okay, and now we're ready to graph our function. Note that we've got these 2 points, and we know that the multiplicity of this 0 is 1, so we just cross through the axis. So we're going to follow our asymptote and then go through those points. Follow the vertical asymptote. And then over on the left side, we obviously can't be down here, and so we need to be up above. Okay, and we would also know that from this negative 2, which that 0 of the denominator had a multiplicity of 1, which means that the behavior on the left and right of this asymptote are different. So there's the sketch of our function.